Yep, it was a cold one last night, so I thought what a better opportunity to explain how the cold actually affects batteries and things that I've learnt along the years, especially when you're trying to start a car, and why we have problems when it's cold. And I'm going to cover a few things, get straight into it. What's the reason why then in the winter your battery doesn't particularly seem to be as strong as it would do maybe in the summer, or even run flat and you've had to jump start it? Very simply, obviously your car is using a lot of more power, and you've got to have the heating on more. You're using, perhaps if you're lucky enough to have heated seats, heated steering wheel, heated windscreens, rear demister. It all draws a lot of power, in particular a lot of current from the battery. Now, the actual current, the best way to understand it and think about it in a sort of very mechanical way is think about volume of electricity going through a cable. So let's say this is one of your cables here, and it's got electricity flowing through it. So the current coming through this, if you imagine it being, say, a fluid, water for example, you're going to have less of a volume of water going through that than you would do that. And that's simply because obviously the core diameter of this tube, or let's pretend it's a cable, is bigger than it is with this. So you're going to have more volume of electricity, more electrons, more current flowing through it than you would do with a smaller cable. So that's a simple way of looking at it. So taking that principle, I've got some jump leads here, which are some cheapy ones I bought. I lent some good jump leads to a friend of mine. Guess what? My car needed to be jump started. I didn't have any, I had to buy them, and it was just a cheap shop that I found them in. Now if you look at the size of the cable, it's not particularly big. Now they're okay, they might get you out of trouble if your car's just gone flat. Let's say you left the lights on, you went to the shop and you came in, you couldn't start it. So these might just be able to get you going. But depending on your car, bigger cars generally need more current, and they need a bigger, more quality cable to be able to transfer the electric charge from one battery to another, as in jump starting it. So I'd recommend, if you're going to buy some cables, jump leads, get yourself some decent ones which are a lot thicker. And if you look at these are designed for sort of maybe about 2 litre upwards. They're a lot more chunky, a lot more substantial, and these I've had for years. It's a good idea to check them, make sure there's no nicks in the cables. I keep these in the boot. I drive automatic, so you can't jump start them. That's why I've got these. Another good thing about this particular type is it's got a cover on the end of it, plastic cover, so it insulates it. Cheap ones, they don't have anything, and I can't tell you how many times I've actually ended up sparking the ends of these, and I'll tell you why. So using the jump leads is the next thing I'm going to talk about. And from my experience, the amount of times I've actually seen this happen, where somebody's gone to jump start their car. You're obviously usually in a hurry, you're trying to do it quickly, and you're concentrating on the battery. So you're like this, you concentrate on the battery, you've connected the negative and the positive together like this. And I won't do it just now because the other two ends I know to look for to make sure that they're safe. So let's pretend that's connected on the battery there. These two ends, inevitably, the design of these is such that when they're hanging like this, they end up touching. And when they're touching, they're going to short your battery out. You're going to get sparks, and if you've got fuel around or anything, it's dangerous, plus the fact you're going to damage the cells in the battery. These things are going to get very hot very quickly. So when they're hanging on there like that and you connect one end up, it's so easy to forget what's going on at the other end. So my tip is, when you're ever jump starting a car, don't connect the battery first. Always think about the empty end of your jump leads and connect one to the other, but on the actual cable. That way they're hanging separately, they're not going to touch, and you're okay. Now go to the other end and you can connect them up safely without the risk of anything sparking from underneath, because they're not connected. Alright, so that's a good little tip. And the other thing we'll talk about when selecting a set of jump leads is try and get a longer length than you actually think you would need. 3 meters is probably your minimum. So many times I've gone to jump start a car. Some cars the battery's in the trunk or the boot, some cars the battery's in the front. So you're trying to jump start it, and inevitably the cars are never quite in the position that you want. So I've actually tried to join jump leads together, but then you lose this all-important current which I just talked about. So if you're going to buy jump leads, get the ones that are insulated, get yourself a decent thick core diameter of cable, and the last thing is make sure that they're long enough. I would personally go for 4 meters. I've got some here which I bought, which actually, these are actually 6 meters, and you know, 3000 amps it's got rated on here, so this is good for starting cars sort of, I would say, just, you know, 3 litres and upwards, and my 2 cars I've got are bigger than that, so I use a much heavier gauge of jump lead. Right, that's jump leads talked about. So let's talk about the actual batteries. Now, reason the batteries can go flat and give you problems in the winter, it's just simple physics of it really. The batteries, let's talk about the actual what's going on. The batteries have got an electrical chemical reaction that goes on inside, the electrolytes, the ions, etc. And it slows down when the weather's cold. They're a lot happier when it's warm. When the weather's cold, that chemical reaction slows down, and the power that you're getting out of the battery then depletes. Secondly, obviously when it's cold, you're using heating in the car, you've got your heated windscreen, maybe your heated seats, etc. It's going to draw a lot of current, and especially with what's going on with lockdown right now, we're not using the car as much. So when the car's driving, you need to sort of be keeping the revs at least over about 1500, 2000 for what they call the alternator and the voltage regulator to start charging that thing. And you need to be driving for about 10-15 minutes for it to actually start getting a good charge. If you're just popping down the shop and you're not giving that car enough time to charge, and even if you're sitting idling, it's not going to charge the battery up as much as it would do when you're on a highway, on a motorway, doing a nice steady sort of 60-70 miles an hour. The other thing I'll say about batteries is you've got to remember you've got to get the right battery for your car. Yes, any battery would work, that's true, but you can see physically the size of that battery and the size of this battery in dimensions are different. Now this one is out of a Range Rover, this one is out my Mercedes. Now even though fortunately on my Merc I've got 2 batteries, the smaller battery, this particular one here, is used for just the electrics like the folding roof, etc. So it doesn't need to be quite as chunky as this. This one is for the Range Rover, and it has a lot more, and that's the only battery that the vehicle has, so it's got to deal with a lot more. Range Rovers are really power hungry vehicles, so you'll see things on the battery saying about cold cranking amps. You'll see amp hours. The amp hours and the ampage are specific to the car. You need to make sure that when you're buying a battery, my recommendation is just get the best that you can. Don't go looking for one that you think is going to have it's exactly the same spec. I've seen this before where it's a cheapy brand. It might say exactly the same on paper. In fact, the numbers might even be slightly better. But when it comes down to electrics and things, I personally really would say get the one that's specified for your car. If it's Mercedes, get a Mercedes battery. I've had it before where I've gone to an auto store. We got something in the UK called Halfords. It was supposed to be a like-for-like OEM battery. Gave me all sorts of problems. I took it back. I bought the Mercedes ones. I could leave my car out there for 3 weeks and never use it, and it will start first time every time. Great battery. The other one kept coming up with low battery warning. So that's batteries talked about. Checking the battery. Right. If you've got one of these, multimeter, voltmeter, select it to DC, which is volts with the straight line. The wavy line is AC. Okay, so you want DC because it's obviously standing for direct current. And these batteries here, the reason I've got these are actually old batteries out of my car. This one I had out the Range Rover, and even though it wasn't completely worn out, I kept it because it's handy to have around the garage. You know, I'm doing stuff in the workshop and things, I can still run power off it, no problem at all. So you've got your prongs here from your multimeter, put one on one side, one on the other, and it will tell you what the voltage is. Now on this one I've got 12.45, I'll put that there, you might be able to see it. So 12.45, there we go, which is alright. Batteries can go anything up to about 13 volts when they're in good healthy order. Obviously I put this the other way around, it doesn't matter, I'm just going to get a negative reading. So let's say minus 12.45, just the way that the current is flowing. This one is a slightly smaller battery, but it doesn't mean that the voltage will be less, it just means that it doesn't have the same current which I touched on earlier. So this one is going to be, yeah, it's 12.3 volts there. So when you're charging the battery up, you can charge it with a trickle charger. By the way, I like to always keep these plastic caps on. It just, even if you just got it on one, it just saves any risk of things. If there was something to fall on it, I don't know, say I had this ruler that's resting against it and that touched, that's going to get red hot. It's going to end up damaging obviously the battery, but more importantly, it is a fire hazard. So it's always good to keep these terminals covered. Yeah, if you want to charge these batteries up, I find I keep them charged just as a reserve. If I ever do get issues with can't start in the car, I can always lift the battery straight to that car, get my jump leads and jump start the car. I don't have to muck about with getting another car. So if you're fortunate enough that you've got an old battery, you know, keep it charged up, ready to go. It should hold the voltage if it's good. This one here is my little trickle charger. You can see that the light is green, so that means that it's fully charged up. That I've actually, just show you, I've run I've joined the cable on here, made it slightly longer, and it goes all the way, and it's charging up that Range Rover there. Now the reason is that because of lockdown hasn't been used. Not that it wouldn't start, but I like to keep it just topped up because unfortunately inherently on Range Rovers they do tend to like to be driven, and they can be tricky to start if your battery's low. So I've just got a little trickle charger on there, and I'll leave it on if it's not being used. Just keeps it all nice and topped up. Right, so enough talking, let's go and have a look at the car. I'm going to now run through how you know if your car is actually charging the battery. So we're going to talk about alternators, voltage regulators, how to test it, and right, let's go and have a look. Okay, so this is inside this L322 Range Rover. What I've got connected here, these are actually the battery trickle charger that I just showed you. On most cars actually there's a way of charging or connecting the jump leads without having to go directly to the battery terminals. This one here is just goes straight to the chassis, and this one goes directly from the positive to the battery, just goes through the bulkhead there and is connected up. So I can charge it quite easily without having to get the cables buried in the back in the battery there. Now most cars are negative on the chassis, so anywhere where there's metal contact to the chassis will be your ground or your negative. Right, so if you're jump starting it, these are the terminals that I would use, and you would find that it's a lot easier to connect it there, especially if you're also trying to change that battery at the back. But you do want to lose any of the settings on the car, like the electric windows that can go out of sync, the radio, etc. So if you've got a spare battery like I have, you can connect it like I've done here to these auxiliary battery terminals. Keep those connected, disconnect the battery terminals on the battery for the car that you want to replace, take it out and put the new one in. You can imagine if I try to connect the jump leads to those terminals at the back there, they're going to end up falling off, and as soon as one of those cables pops off, you're going to lose battery, to the car, and the car is then going to lose its memory. So having a second battery allows you to change your car battery without losing power and your settings to your vehicle. Obviously you need a second battery. Now you can, if you've bought the new, when you buy the new battery, you can use your jump leads, connect it like I've done there. If you find the positive on your car away from the battery terminal and anything on the chassis on the ground, and if you connect it that way, you can do it, but remember you've got to then try and fit that new battery in the back, so you've got to make sure that the other end of your jump leads don't fall off again, otherwise you'll lose power and then you lose your settings. Right, let's have a look inside. Right, now what I've got here is a handy little gadget. I'll put a link down actually in the description. It's I just got it off Amazon. It was like £8, and it's just a little cigarette lighter. It's got a USB adapter on the top. It's got a little thermometer there, and it tells me two things. Importantly, it tells me the voltage. So I've got 12 volts exactly in the car at the moment. I've got lights on and things, so it's probably drained it a little. And -4 is your temperature. So there's not many cars that I've ever had actually where it tells you the internal temperature exactly. It's normally just a gauge. Right, anyway, enough said. So how to tell if your car is charging using the alternator of the car and is actually giving charge to the battery. In other words, how do you know if your battery is being recharged by your car? I'll sit this down here. You can just about see there's 12 volts there, right? And start using buttons and things on the car. You can see already we dropped down to 11.5 volts. Turn the radio down. Is what the battery has currently at the moment. So to find out if your car is charging up your car battery, obviously the first thing you need to do is start the car. So let's start it. Right, so car's started. So we've got 14 volts sitting there right now. Sorry, it's shaking, I'm so cold. 14 volts is what is telling me that the car is producing via the charging circuit, which is obviously by the alternator. Now, just to explain, an alternator is, just see it as a big motor. As the motor turns, it produces a current, produces electricity. A voltage regulator sits on the back side of that round motor, which keeps a consistent voltage to give the battery the right charge that it's looking for. And in this case I've got 14 volts. I would say anything from about 13.8 volts to about 14.2 is the norm. It depends on your car. So 14 volts, I've got a good charge there. It just dropped and went back up. That's because I hit the accelerator. That's the voltage regulator doing its thing, and it's maintaining that 14 volts. Right, let's put some load on the car battery now. So if I press the rear demister, that usually uses a lot of current. Let's see what that's like. Oh, there we go, 13.7. So what's happened there is the car is now using a lot of battery, using a lot of current, especially with heated circuits like that, and the voltage regulator is still maintaining a good charge at 13.7 volts to keep that battery being charged up to the correct voltage. If I come off the if I take power off the battery, as in demand, see how the volts went back up, but it hasn't gone any further. It's still maintaining that 14 volts, which is important. So to test your alternator, you can get one of these little gadgets, really helpful. If the voltage wasn't going up and wasn't staying consistent, you've either got a problem with the alternator or you've got a problem with the voltage regulator. Now you can actually change the voltage regulator, I've done it before, but usually they come part of the alternator, so you're probably best putting a new one on. Right, another way to test it, if you've got a multimeter, go back to putting it on the DC. Okay, you can connect it to the battery in the car, as in the engine, but as we're inside the car right now, let's do it this way. We're going to connect it into the cigarette lighter. Now inside here, where this connects in, the little end part there is your positive, as in your 12 volts to the positive of your car. This is the chassis, it's negative. Now if those two touch, as in inside there, you're going to blow a fuse. So if you're very careful and you've got yourself a good set of decent probes off your multimeter, you put the red one in the middle, being very careful not to touch the outside because that will short it. So right down in the middle. Okay, you can see that there's nothing on my multimeter at the moment. Now if I touch the outside, there you go, I've got 14.9 volts there, 14.2, so it's fluctuating slightly, but all I've done there is basically touch the negative and the positive in the car. Right, well I hope that helps. I'm not going to go on anymore. Can you do me a favour, and if you put some comments down, I might do a few more videos. And I'm going to turn this camera around. Yeah, I really hope that helps, because when the weather's cold like it is right now, there must be a lot of people that are getting these issues. So if you wouldn't mind, if you like this sort of thing, then by all means subscribe. If you don't like it, don't subscribe, but it helps me because I've noticed that I've been on YouTube now pretty much since the beginning, and I've never really thought much about it. And I looked at some of my old videos and they're in the hundreds of thousands of views, where I've maybe done a quick help guide on how to reset something in a car, and I like to try and help people. I'm on forums and things, so you know, if there's something that you're stuck on, if you think I can help, I do diagnostics as well. I might run through on how to use some of the tools that I've got, which you can readily available, won't cost you the earth, and will give you that all important fault code on the car, so that you can help diagnose it. Or even if you just want to know what it is before you go to the garage, then you know that the garage isn't trying to con you. So if you like it, hit the old like button, as they say. If you don't like it, don't hit it. Thanks very much for watching, and I look forward to seeing if there's any comments I can answer. Bye for now.